Hello and welcome back again to another video here on YouTube. I'm calling the series Let's Talk WireShark, and in this video we'll look at some NMAP scans. So I'm gonna conduct some of the normal, very standard NMAP scans. Not a lot in this video. I think I do one, then let's talk about it. And I started WireShark on my receiver machine here. It's a machine where I started an Apache server, as you can see right here. So I have an Apache server installed. So I basically started that, and if you go to the localhost, you'll see that I have, some application installed, but it's just the index of the root of my Apache server. So the idea is that I use my IP address on this virtual machine, and then I have another virtual machine which I cannot pull in over the window, it would seem. And let me just show you the virtual machine. So I minimize the window, and I have another one running here. It's a Ubuntu. Doesn't really matter which version it is or anything. I just installed NMAP. It's like literally like 5 minutes ago installed on this virtual machine Ubuntu, and that is going to be my attack machine. It's going to be on my other screen here, so I can maximize this screen here. So what we're going to do is basically start the sniffing mechanism on WireShark on the ETH0 here, the one you see in the top. That is my network card. I could do any, but I'm just thinking this is the right one to take. You will see other packages here if you wait long enough. What I'm going to do is basically just start the NMAP scan, which is a standard NMAP scan. So I think I should better show this. It is just this. So I'm basically just saying, I'm going to zoom a bit on this. It's in my language. Fantastic. So it basically says NMAP and the IP address of this machine. This machine's IP address here, it's called 192.168.116.130. So that's the subnet. It's 192.168.116, and 130 is this machine. 128 is this machine to the left that I'm going to attack. So the victim is 28 and the attacker is 130. Now let me put this on the other side now. And let me just maximize this window one more time. We're getting traffic already, it seems. So I'm going to clear. Run the NMAP scan. And then I'm going to shut off the recording. I'm gonna show the result of the NMAP scan, and that's gonna be, whoops, wrong one. There we go. The result is gonna be that port 80 is open, which is also true because I opened my standard web server and I have nothing installed, so it's basically just port 80. And this particular scan scanned the first 1,000 standard ports, and 999 of them are closed and one is open, which is true. So let's have a look at the traffic. First of all, I think we should filter something out and only see traffic that is coming from the 130 machines. Let's go ahead and do an IP address equal to, then I do this 130. So now we're only seeing traffic that came directly from in some way 130. Now let me just see. And I think we should also say IP address equal to 168. I think I made an OR, should be an 128. Alright, so let's see. Maybe we should do it as an OR statement. No, definitely not. I totally forgot about that. So I think this looks like our NMAP scan. So let's talk about it. What we see in the very start is looking like the attacker is sending. Now maybe we should. This is extremely zoomed in, so maybe we can zoom out just a bit. There we go. Now we have a lot of stuff going on here. You can see this. So basically, I think I'm gonna pull this a bit there and then zoom in a bit for you guys. I think it should be fine. Let me see how much I can save. I'm not gonna make it completely impossible to look at, but you know how it is when you're gonna fix this. Great. Okay. Alright, so what you see here is a package coming from 130 to me. I'm 128. It's a TCP package. It's a SYN package. It's trying to open a synchronization message, which is a part of the TCP protocol, and it's sending it to port 80. Now, I have port 80 open, so this is gonna go well. Now, the other one it tried to send is to port 443. And the reason for that is that port 443 is actually the one used for TLS, or you call it HTTPS. Now, my web server have no ports open or whatsoever that allows HTTPS traffic. So basically this is going to resolve pretty fast in a reset and acknowledgement. You can see in the WireShark here, and it's difficult to see, I cannot zoom on the lines, but you can see that here, that the very first line is a solid line, and there's some dotted lines, and the dotted lines basically means that this message has nothing to do with the one that I marked. I marked number 27, and that's going to go directly down to 29, which is the reset and the ACK, and that basically resolves as this is not open. There is nothing going on that port. It's basically just a reset message with an acknowledgement, and nothing more will go on port 443 for this particular moment. So the next package we see, and this is going to be the port 81 here, it skips, let me just see, this one and go directly to 28, and it's a SYN ACK, and then goes directly down to the acknowledgement package, and then we're gonna do let me just see, a reset. So basically the very first thing that starts right here is NMAP trying to find out whether port 80 is open by doing a three-way handshake. So if we look at this, we can see that number 130 sends a SYN flag to 28, the victim. Let me just say the attacker from now. The attacker sends the SYN flag. The victim sends the SYN and ACK, and then the attacker sends the acknowledgement. And that is the connection that is quickly after that being shut down. So port 80 is open, and that is the way NMAP is doing it. What you're seeing from now on, and since we know this is why we can say, and I can say, what you're seeing from now on is all connection attempts to other ports. There's no direct pattern in all of this, unless you know NMAP, unless you know which ports are being scanned for. So let's take a minute to just press the top packages here and see that the very farthest down jumps is to packet 2031, it seems, which is the reset message. So we can go directly to the next message. It is package 36, which is a SYN package. Now it just repeats itself, and it says, okay, so the attacker wants to know if port 199 is open. And what we see is that, and the dotted line in next, 38 says it is not open. What you see on line 37 is the attacker asking for port 23. Is that open? And that's being reset acknowledged by the victim. It is not open. And I could continue saying this, and you can see the small, bracket square, what you're gonna call it, in WireShark. The very first message there, and then there is a dotted line, and then after that you see the response. The reason for the dotted line is just the way the traffic is intercepted. It's just the what you call the the order it's being received in. There's no direct pattern. Well, some of the times you see you got double resets and stuff like that, and the only thing that really happens is just this. Now, then you see something new. It's like you see it again. It's like this is the new message. You see that the attacker one more time tries to verify if port 80 is open. Now this is weird, right? And then the victim says yes, it's open. And then you get the acknowledgement package, and then far down you get a reset package. And then you scroll down through the traffic and look at what do we have. All kinds of different ports that's just gonna be asked for, really. This is the standard NMAP scan. It scans for the first most commonly used ports. It's not the first in that way, like 1 to 1000, but it is the most commonly used ports. And we can just tap through and see, oh, we have a lot of stuff here. And it just continues and continues and continues. And the pattern is really easy to look at because we have nothing of the ports. You can basically just take the SYN flag sent from the attacker to port 5431, and it's being reset ACK from the victim, and basically saying, yeah, we have nothing. That's the standard NMAP scan in WireShark. This is how it looks. This is the pattern you should look for. That if someone now let me show you one more time the attacker's NMAP scan, and we're gonna pull that in, and the machine is sleeping. And you can see that I ran the NMAP scan here, and this is the command you should think this is what someone ran. Now, let me just be clear. If you do any small script in Python or whatever you're gonna do, you're gonna see the same pattern in WireShark because it is just a normal TCP connection request. Nothing special about it. It is not a hacker method. It is not a atypical connection request. It is basically just how it looks when your port is closed. And you have standard response. Depending on how your system is set up, this can look very different. So I'm getting a response, but not. What if I'm not? What if my firewall is saying, I'm going to be quiet? And this is what you usually call a filtered. You filter it out, so you see nothing. You get nothing from it. What does that mean? Right? And it could mean that it's open or it's not. It's really difficult. So depending on which kind of way the firewall also accepts a connection, maybe it's only for UDP. Maybe it's only for another protocol. Maybe you need to identify yourself in some way before getting into it. Then you're just going to get no answer. But it doesn't mean that the port's closed. So really just saying that this is the most open way without doing fiddle faddle and magic and stuff like that. I'm going to show you how the NMAP scan is looking in WireShark. Alright, so I think time is also getting close to 16 minutes. And I just want to say that I hope you learned something from this video. I hope you learned something about NMAP scans, and I hope you learned something about how it works, and I hope you learned something about how the TCP protocol works, and I really hope you learned how to read the traffic better in WireShark. No experts or anything, just better, small steps at a time. If you did so, or if you like my video, please consider subscribing to my channel. And I really hope to see you out there and give me a shout out. Basically that's it. See you. Have a nice day.